Alright, so hi, my name is Ethan. Today I'm going to be doing my presentation on port forwarding, which, in my opinion, is one of the more underrated sides of networking and how devices interact with each other. Alright, so what am I going to talk about? So, first, we're going to have our introduction. Why is port forwarding important? Our key concepts, terms and processes, the real world applications of port forwarding, which there are plenty, the impact and relevance in networking as a whole, a conclusion, and then, of course, our works cited. So, a little introduction here. So, port forwarding enables external devices to reach services located on private local networks through this networking technique. So, basically allows public connections to reach private networks and specific devices on those private networks. So, this process helps users access applications such as game servers, security cameras, and web servers, which are all located behind routers or firewalls. So, if you want to have a secure network, this is the preferred way to allow connections to go to those devices while still being in a semi-secure environment. So, port forwarding enables secure and efficient traffic management between public and private networks through its ability to redirect communication requests between different address and port number combinations. So, basically, exactly what it says, it allows the communication between public and private networks and devices on both ends of those networks through different address and port combinations. So, basically says what address and port combinations can be opened to public networks. So, why is port forwarding important? So, port forwarding functions as the fundamental component of computer networking because it enables authorized access to private network services. It's essential for remote access. Users can have the ability to access home security systems and work PCs and game/web servers through remote connections. So, if you're trying to access for any reason your computer or server or anything from outside of your local network, port forwarding is going to be almost essential for that. So, the functionality enables users and businesses to operate websites, FTP servers, and game servers through NAT, which we covered in class, but if you're not familiar, network address translation. So the system optimizes traffic distribution to reach the right device without revealing the complete internal network to unauthorized access. So basically it's a security thing. You don't want people to have unrestricted access to your entire network. That would be a disaster. Probably every web server would get hacked every day. So the system provides method to reveal only required ports, which reduces the exposure to outside threats. Kind of just the same thing as I just said. Most network services remain inaccessible to users who are outside the local network because of port forwarding. So, as we discussed in class, but in case you're just a casual viewer, there's a million different ports on a network. Well, not actually a million, but several thousand. And port forwarding only allows a specific few ports to be available to the public. All right, so key concepts in port forwarding part one. So there's a couple of these, so just bear with me here. So IP addresses, obviously something we covered in class a lot, but if you're casual again, every device on a network has an IP address, internal and for the network as a whole, external or public. External traffic receives direction to its appropriate internal IP address through port forwarding. Ports. A port functions as a communication endpoint. Some examples include the HTTP protocol, which operates on port 80, and the HTTPS protocol, which operates on port 443. So, if you've taken server-side web development, port 80 will be familiar. And port 443, that's just kind of the HTTPS equivalent. So, NAT, network address translation, and PAT, port address translation, these are two things that we covered in class as well, but very important to port forwarding. So the NAT system enables numerous private network devices to access the internet through a single public IP address. So basically, it translates your private network address to a public address, and assigns a certain port to basically keep it all intact. And that's brings me to PAT. So PAT is a part of NAT which differentiates internet traffic by using unique port numbers for each connection. So basically, like I'm saying, your exact private address isn't sent as your public address because they're not the same. So what your router does is it translates that private address to a public address with a certain port number combination. So it's basically a port IP address combo. The combination of NAT, PAT, and port forwarding enables proper network trafficking. So all these three things together really work in a synchronized effort to keep your network secure and allow proper network traffic to flow through your whole network. So without these things, your network would either not be secure at all or it wouldn't be able to access the internet. Let's go to our next slide here. Alright, so key concepts in port forwarding part 2. So these ones are a little bit different. Some of these we did talk about in class though. So port forwarding, or port mapping, the process of linking external ports to internal IP addresses, and the port functions as port mapping. So this is kind of similar to NAT and PAT in my personal opinion, but it's just specific to ports. So it makes it more secure as a network. So for example, an external port could be 8080, but the internal port on that actual device would be port 80. So it's very different. Default gateway. So a default gateway basically functions as the router which enables local devices to access the internet connection or other networks. This device is where port forwarding rules receive their configuration and is usually the default gateway. So basically, on 90% of personal routers or home routers, you're going to find that the configuration for those port forwarding rules is actually done in the default gateway. And I'll show an example of this later, but basically all you would have to do is type in your default gateway in your web browser, and you'll see all the settings available to you. But then again, that can vary from router to router, company to company, and so on. And obviously, there's security behind that too. Usually, a username and password is required. So, all right. But now let's go over the different types of port forwarding. So you have static port forwarding, which is manual and permanent mapping. This is the easiest to set up, but also could be argued one of the less secure options because hackers can find a way to that exact port. But it's a manual and permanent mapping. This is used for like web servers and things of that nature. So dynamic port forwarding, temporary and often used in tunneling protocols. So this is more like one and done type applications used. VPNs use this sometimes. It basically, the port number changes in every connection. So UPnP is universal plug and play, and it automatically opens ports, but may have security risks, which that one's kind of easy to understand. Ports are opened automatically, but hackers or people of malintent can easily get into those open ports if they're not assigned to anything in particular. All right, here. So terms and processes, part 1. What is needed to port forward? So a lot of these we're familiar with if you have taken this class. So a router, obviously, the device enables your home or business network to access the internet. The device manages internet traffic by connecting to your devices and to web access. So in port forwarding, this is kind of be your home base of where all your port forwarding rules, or most of them, are set up. Public IP address. Your internet provider assigns this address to your router. The world recognizes your network through this address. So this is how the address that outside connections are getting in to your network. And for port forwarding, what this basically means is this is how they're going to access. And then this is the IP they're going to access. And then the port is going to be on the end of that. Private IP address. The internal network uses this address format to identify devices. So, and then there's a little example one But basically, your router will translate your the public IP address it receives to the private IP address, and that ties back into NAT and PAT, of how your router decides which connections are going where on your private network. So, and then lastly, this one's pretty simple. Port numbers. Each service and application receives its own identification through port numbers. Example, websites operate on port 80. We already kind of talked about that. But yeah, connections in a specific IP address, each type of connection or each connection itself will receive a different port number most of the time. And there's, like I said previously, over 1,000 different combinations. And each one of them are theoretically available for use. All right, terms and processes part 2, how it works. So this is kind of like the step-by-step on how port forwarding actually works and how connections go through port forwarding. So your router receives internet requests through its public IP address, which serves as the entry point. Your router then checks its port forwarding rules in its firewall. So it says, is this an allowed port request? Is this port open for use? The request reaches, if so, that's an important part, the request reaches its destination device and port through the router's forwarding system. Now, important to note here, if it was not allowed in the firewall, this step will not happen, and neither will the rest of these. So then, step 4 here, the device sends its response back to the internet user through the router. Port forwarding then enables your router to direct internet traffic on that port to your computer. Good example is 25565, port 25565, when you want to host a Minecraft server. So if you have port forwarded, your users will be able to connect to your server on that port. But if not, out of luck. That port might be in use, or you might want to try a different port, or maybe you just can't get port forwarding set up. So next slide here. So here's a great example diagram of how port forwarding works. You can see the internet as a whole, connecting to your router's public IP address with a specific port number. And then your router then looks for through its connected devices for the private IP and the port number that matches. So you can see 443, that connection is good. So, but if it wasn't even allowed in the firewall, that port wasn't open, then it wouldn't have gotten past the router at all. It would have just stopped right there. All right, so here's a default gateway example. So this is a common, or semi-common way that you can add port forwarding rules into your router. Of course, this will vary from router to router, company to company, but this is kind of a good example to show you can enable your port, a description for it. It's inbound port, so you can have a range of ports to be available. Connection type, TCP and UDP are the common ones, or you can set it to both. Private IP address, so this is the private device you want to have enabled the port for, and then the private port. So, all right, and then the real world applications of port forwarding. This one's pretty simple. Gaming servers, players enable multiplayer games players enable multiplayer game access. So some examples we went over earlier: Minecraft, Call of Duty, through port forwarding, which allows internet connections for others. So if port forwarding wasn't set up, you wouldn't be able to access your servers, your private or your servers that you've set up. So remote desktop access, we also went through this one earlier. Users establish connections to their home or work computers through distant locations through remote desktop protocol, RDP, which operates on port 3389. So that's a good example. A lot of businesses use remote desktop applications. I personally use one. And without port forwarding, that would not be possible. Security cameras and DVRs. People access security system live feeds through port forwarded camera devices. So if you think about it, a lot of security cameras are able to be accessed through the internet nowadays. So without port forwarding, that would not be possible. Web hosting, small business together with developers operate websites from local machines through, like we talked about earlier, HTTP port 80, HTTPS port 443. So this is a huge one. If you've taken server-side web development and you've just out of curiosity or boredom's sake tried to connect to your web server that you have running on a different machine, you'll notice if it's not in the, sometimes it won't work even through your private network, or it won't work, it definitely won't work in a public network, and that's because that port is not forwarded on your network, and your router is not allowing outside access to that, and it's not set up, so it's not even a matter of allowing, it's not set up. So VoIP and video conferencing, basically the stability of connections like Skype and Zoom can actually be improved through port forwarding because that port is always set for that application, so it allows a more consistent connection, less data is lost, speed is improved, so on and so forth. Alright, so impact and relevance in networking as a whole. So it enables seamless communication. So port forwarding functions as a critical tool which enables direct device communication across different networks while preventing incoming traffic through NAT and PAT. So basically it allows the connections that are supposed to go through, and the ones that aren't. Supports remote work and connectivity. So the remote first world depends on port forwarding to provide access to internal systems and services through methods that avoid expensive or complex infrastructure requirements. So if you're just a starting up company or something along those lines, or just have a personal website set up, this would be a lot easier to do than having a remote server somewhere host your website. Boost network functionality. So the technology enables small offices and developers and hobbyists to operate servers and services through a single public IP address without needing separate dedicated public IPs for each device. So basically, you can host a lot on your own private network. Well, it would go to a public network, but you get my point. Kind of similar to the last one. And highlights the needs for security awareness. The power of port forwarding requires proper configuration to prevent cyber attacks because it exposes systems to security risk when not used correctly. So this one's very straightforward. I mean, if you had every single port open, like I said previously, that would be a huge security risk. I mean, most companies would get hacked on a daily basis, I'm sure. So the ability to understand port forwarding enables users and IT professionals to handle networks with enhanced efficiency and security and flexible management capabilities. So this is a very configurable tool. There's lots of options, lots of ports, lots of IPs, and you can set it up the best way that fits your personal environment or your professional environment. So let's kind of go over the summary of the key points here. So port forwarding allows external devices to reach services located on private networks through routers. The implementation of port forwarding enables remote access and hosting services and enhances network efficiency. The fundamental concepts in port forwarding include IP addresses and ports together with NAT, PAT, and a default gateway for proper port mapping. The process directs external traffic from public IP addresses and ports to particular internal network devices. The real-world applications of port forwarding include gaming servers, remote desktop access and security systems, and web hosting. Network management requires a solid grasp of port forwarding to achieve both security and efficiency. And then, of course, here's my works cited. So I hope you enjoyed the presentation, and Professor, if you're watching, thank you for an awesome semester.